Okay, so here's a tutorial video on lesson number 20, which is factoring trinomials by grouping. Lesson 19 was on factoring 4 terms by grouping, so now we're doing it with 3 terms. There's a couple of steps involved in setting it up. So let me show you the steps first, so you can copy them down if you don't have them. The steps are to multiply a times c. Those are the coefficients, so if you have a trinomial, it looks like this. It has an ax squared plus bx plus c. So when I say a times c, I mean this number times this number. Number 2 is list factors of ac. So when you multiply a times c, you get some number ac, and you want to list out all of its factors, right? So a times c, whatever, number times number, you're going to list them all out. Then you want to choose 2 factors that add to b. So you're going to choose one of these that adds to this. Then you're going to split b into 2 terms, and then you can factor by grouping. So let me show you what that looks like with a more complicated example. I'm going to pick question number 24. Because I want to show you what it looks like if it's hard to find the factors. So let me rewrite this question. Negative 15x squared plus 42x minus 24. I'm going to grab my select tool and pull it over to a blank page so I have some room to work. Okay, now doing this can be really hard without a calculator, so I'm going to pull mine up on screen. I'm going to use it a couple times. If you don't yet have a TI-83 or TI-84 calculator, you really need to get one because this homework is hard without it, so are tons of the topics that are to come. So here's what I'm going to do. I'm going to do negative 15 times negative 24. That's a times c, and that gets me, let me switch the pen tool. So this was a, this was b, this was c. When I multiplied a times c, I get 360. So the question now is, what are the factors of 360? What are the factors? So I'm going to start listing them. Is 360 divisible by 2? Yes, it is. So the first, the most obvious, I think, is 360 times 1. Another option is 180 times 2. Now 360 is a big number, so there might be a lot of factors, but let's work our way through them. This is the easiest way to find it if it's hard to tell what the factors are. 360 divided by 3. Okay, so that means 3 times 120. 360 divided by 4. Okay, so 4 times 90. 360 divided by 5. 5 times 72. 360 divided by 6 is 60. So 6 times 60. 6 times 60. Okay, 360 divided by 7. No, that doesn't work. 360 divided by 8. That works. 8 times 45. Now, none of these have added up to 42 yet, so I'm going to keep going. 360 divided by 9 is 40. So I got 9 times 40. Since none of these have worked so far, I'm going to select them and shrink them to sort of get them out of my way. Alright, let's keep going. 9 worked, but 9 and 40 don't add to 42. So 360 divided by 10. Okay, so I also get 10 times 36. 360 divided by 11 doesn't work. 360 divided by 12 is 30. And that's the number that I was looking for, 12 and 30. You might be asking, why? Because 12 plus 30 is equal to 42, which is that number, and 12 times 30 equals 360, which is that number. Okay, so 12 and 30 is our magic numbers. They're both going to be positive, positive 12, positive 30, because they have to multiply to positive 360. So let's split this middle term up into 12x plus 30x. Bring down the other two terms, so negative 15x squared. Bring down the plus sign. Bring down the minus 24. Now if you can split it to there, you're okay. If that part is sketchy at all to you, or you're not sure about it, I want you to pause right now, go to another question on the sheet, and see if you can get from 3 terms to 4 terms. So pick a question. Pick number 20 or number 21. Okay, if you're watching, I'm going to assume that you have tried one and you've succeeded. If not, then you watch the video again from the beginning. If you didn't do either of those, then you're being lazy and you should do a question. Now that I have 4 terms, here's how I finish it. I group the first 2, group the second 2. This is a skill that we learned in lesson 19, and even lesson 18. I need to factor out a GCF from both of these. On the left-hand side, I'm going to pull out a negative, so negative 3, and I can also pull out an x, leaving me with 5x plus, minus 4. I know it's minus because negative 3x times negative 4 would be positive 12x. On the right-hand side, I'm going to pull out a positive. It looks to me like I can pull out a 6. We'll check that. Leaving me with 5x minus 4. Great. That's the number I needed to use. Now I combine my outside stuff. Negative 3x plus 6. And my inside stuff. 5x minus 4. And I would love to set it equal to 0, but maybe you noticed by now there's a GCF I need to address. These guys are both divisible by 3. So I should factor out a 3, or even a negative 3, it's up to you. Answer will be the same. Leaving me with negative x plus 2. I'll bring down the 5x minus 4. If I want to solve for the roots, so this right here is what we call fully factored. That's an F. Fully factored. But if they want me to solve for the roots, then it means I set it equal to 0. And I solve for x. T-chart. I can ignore this guy. He sort of doesn't matter. And I'm just going to set negative x plus 2 equal to 0. And 5x minus 4 equal to 0. And I'm going to solve for x on both sides. On the left I do minus 2 minus 2. I get negative x is equal to negative 2. You may not need to think of it like this, but I like to think of it as dividing by negative 1 to cross out the negatives. And I get x is equal to positive 2. On the right-hand side, plus 4, I get 5x is equal to 4. Divide by 5 on both sides to get rid of the 5. And I get x is equal to 4/5, or if you love decimals, 0.8. Either one of these is fine. So those are the roots of a nice complex example. If you want one more, I'll do one of the easier ones because I've already demonstrated how to find the factors of a large number. So let's do an easy one. I'll do that right on my handout. Let's pick one. Let's do number 21. So if I'm going to do number 21, I want to multiply A times C. A times C is going to be negative 20. If you don't know how I did that, it's negative 5 times 4 is negative 20. Now I need to list out the factors. That's going to be 10 times 2, 4 times 5, 20 times 1. Now in order for this to multiply to a negative, it means that one of the numbers must be negative. If one of them is negative, then it means sort of like I'm subtracting, right? So which one of these pairs of numbers will work to subtract and get me 8? I'm going to rewrite so I can actually do some work. I'm thinking that 10 minus 2 is 8. And I'm thinking that because it's true. So I'm going to split it into 10x minus 2x. I'll bring down the other two terms, the plus 4, the minus 5x squared. And now that I have 4 terms, I'm going to group them. I'm going to pull out a negative from both of these. So I'm going to pull out a negative 5x, leaving me with x plus 2, x minus 2. Remember, because negative times negative is positive. It's the one mistake I see more often than any other. On the right-hand side, I'm going to factor out a minus 2, leaving me with x minus 2. Now, the inside of the bubbles are identical, so I know that I've done the right thing. I'm going to do negative 5x minus 2. That's my outside stuff. And my inside stuff is x minus 2. To solve for the roots, I set it equal to 0, a t-chart. On the right side, the answer is just 2. And on the left, I'm going to actually solve for it. Negative 5x minus 2 equals 0, plus 2 on both sides. I get negative 5x is equal to 2. And I'm going to divide both sides by negative 5. Leaving me with my second root that x is equal to, you can put the negative on top or bottom. I like to put it on top, so negative 2 over, not 2, negative 2 over 5. You could write it like this with the negative on bottom. It's the same thing. It's really up to you, personal preference. Okay, so that was number 21. So good luck with the homework. Actually try, actually think. If it gets difficult, that's fine. Power through. That's how you know your brain is working. See you tomorrow.